Someone's not here. Okay, again, we will talk about exponential decay today. Formula is the same as exponential growth. Y equals A times B to the X power. A is still the initial value. B is still going to be the growth it's actually going to be the decay factor, all right? It's going to be our percentage. The difference is the factor has to be less than 1 but greater than 0, okay? So when it's growing, it's got to be greater than 1. This B value has to be bigger than 1 to get it to grow, all right? When it goes down, when it decays, it has to be less than 1, but it can't be negative, so it's got to be greater than 0. Okay, so this is how we do this. So here, the best way that I can show you is using an example. So it says this, and we use it a lot in science as well. So it says the kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meters of increase in altitude, right, as you go up, the pressure decreases about 11.5%. What is the approximate pressure at an altitude of 3,000 meters? Okay, so first things first, we've got to write the equation so we can figure it out. So we're going to do this. So y equals, what's the initial value in this case? What's our initial value? Go ahead, Cam. 101. That's the initial value. Now we're going to times that by our decay factor. All right. Now, so 11.5% is how much is decreasing. Here's the difference too. So if we change this to a decimal, right? 11.5%, what does that equal as a decimal? Go ahead, David.
0.115.
Yep, because if you move the decimal twice over, that's not the decay factor, because that is how much is decreasing. So what we want is how much is left. So here's the thing. If this is decreasing by 11.5%, right, then what would be left? We would do 100% minus the 11.5%, or we can do 1 minus 0.115, right? Either way, well, 100% minus 11.5%, what percentage would that be? 88 point what? 88.5%. Oops. 1 minus 0.115, what does that give you? 0.885. Okay, so this is the percentage that's left. This is that as a decimal. This right here is the decay factor. You've got to take what it's decreasing by, and you got to subtract that from either 100 or 1, right? And that is going to be my decimal that I use, because this now is what's left after certain amounts of time. And then x is our exponent. So that's our equation. And now there's two ways. How would I figure out the approximate pressure at 3,000 meters? What would I have to do here? There's two ways. First of all, you got to read this, okay? So it says for every 1,000 meter increase in altitude, the pressure decreases 11.5%, right? So what is the approximate pressure? So is meters going to be our x value or our y value? Our x, okay? But it's not 3,000 that we put in there. Why is it 3? Yeah, because for every 1,000 meters of increase, right? It's decreasing that much. So 3,000 divided by 1,000 is 3. So what we would do is we can either do this, put this in our calculator, and then find where x is 3, what the y value is, right? Or we can do 101 times 0.885 to the third power equals, and we'll get our answer. What'd you get?
70.008566663. No, it's one more 6.
One more 6 in there. Okay. And then these are in kilopascals. And so let's think about whether or not that makes sense. It's telling us that as the altitude increases, right, the pressure decreases. Did that actually happen here? Did the pressure decrease from 101?
Yes.
Yeah. Okay. And that's how we do it. So that is the lesson for exponential decay. And now I'm going to help you on some of the questions on the assignment today, which is going to be 7-7 practice. Here.